All right, welcome back to the class. So we have x squared minus x cubed equals 12. Okay, so our equation becomes x squared minus x cubed equals, now we can write 12 as 8 plus 4. Okay, so our equation becomes x squared minus x cubed equals, now you can write 8 as 2 exponent 3 and then write 4 as 2 exponent 2. Okay, now let's move the right component of the equation to the left side. So you're going to have x squared minus x cubed minus 2 exponent 3 minus 2 exponent 2 equals 0. Now let's group the squares at one side, or let's group the squares and then group the cubes. Okay, so we're going to have x squared minus 2 exponent 2 minus x cubed minus 2 exponent 3 equals 0. Okay, so this is what we have. Now we are going to have x squared minus 2 exponent 2 minus, okay, now this part of the equation can be written as, okay, x cubed plus 2 exponent 3 equals 0. Okay, so we can change this part, okay, this part, okay, of our equation to this. Okay, so you can see when this minus multiplies this plus here, it changes to minus, so it is still the same concept. Okay, all right, now we are going to have to here, we are going to introduce a concept here called difference of two squares. Now from difference of two squares, we know that a square minus b square equals a plus b multiplying a minus b. Now let's apply this concept here. So we're going to have x plus 2 multiplying x minus 2. Okay, and then we bring the remaining part of the equation. Okay, so we have x cubed plus 2 cubed equals 0. Okay, all right. Now, let's introduce another identity here. Now, this is known as the sum of cubes identity. If you have a cubed plus b cubed, now this gives you a plus b multiplying a squared minus ab plus b squared. Okay, now let's apply this concept here. Okay, so our equation becomes, okay, x plus 2 multiplying x minus 2 minus, now let's apply the concept here. Okay, so we are going to have x plus 2, and we have x squared minus 2x plus 4 equals 0. Okay, all right, now we have x plus 2 here, and then we have x plus 2 here, so let's factorize. Okay, so we are going to factorize at this stage. Okay, so you're going to have x plus 2. Okay, and what we are left here is x minus 2, so you have x minus 2 minus, now we've already brought x plus 2 out, so this one is out, so what we are left here is x squared minus 2x plus 4, okay, equals 0. Okay, so this part of the equation is multiplying this part of the equation. Okay, all right, now let's proceed. So you're going to have x plus 2, okay, now x minus 2, this and this gives us minus x squared, this and this gives us plus 2x, this and this gives us minus 4. Okay, so this is what we have now. All right, so we're going to have x plus 2. Okay, now we have, let's group x plus, let's organize all the terms here. Okay, so x plus 2x gives us 3x minus 2 plus minus 4 gives us minus 6. Okay, and then we have minus x squared. All right, now we can say x plus 2 is equal to 0. Let's call this equation 1, okay? And then we can say 3x minus 6 minus x squared is equal to 0, okay? Now, by observation, we can see this is a quadratic equation. So let's organize it. So we're going to have x squared minus 3x plus 6 is equal to 0. And let's call this equation 2. All right, let's continue, okay? Now, x plus 2 equals 0. That is equation 1, okay? Now, from equation 1, so we can say from equation 1, we can say x is equal to minus 2. Therefore, x1 equals minus 2. Now, so we know the value for x1. Now, let's find the value for s2 and s3 in equation 2, since it's a quadratic equation. So we can say from, okay, equation 2, x squared minus 3x plus 6 equals 0. Okay, so this is what we have in equation 2. Now, this is a quadratic equation. To solve this quadratic equation, we need to apply the quadratic formula, or we need to use the quadratic formula. And then to use the quadratic formula, we need to know the component in the quadratic formula. Okay, so to know those components, we quote ax squared plus bx plus c is equal to 0. And when we compare this equation to this, we discover that a equals 1, b equals minus 3, and c equals 6. Now let's quote the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Alright, now let's put these values in the equation. So x equals, okay, minus 1 multiplying minus 3 plus or minus the square root of, now b squared, b is minus 3, so b squared is minus 3 squared minus 4. Now a is 1 and then c is 6. Now a is 1. All right, so equation becomes s equals, this gives us 3 plus or minus, now this gives us 9 minus this gives us 24, okay, all over 2. So we are going to have x equals 3 plus or minus, now 9 minus 24 gives us minus 15, okay, all right, all over 2. All right, so you're going to have s equals 3 plus or minus, now we can write minus 15 as, okay, 15 times minus 1 all over 2. All right, so let's continue. Now, so we have x is equal to 3 plus or minus the square root of 15 times minus 1 all over 2. Now, from said, we know that if you have the square root of a times b, this produces the square root of a times the square root of b. Now, let's apply this concept to the equation. So we are going to have x equals 3 plus or minus the square root of 15 times the square root of minus 1 all over 2. Now we know that minus 1 is equal to I squared. Okay, so that is an imaginary number. So we are going to have x equals 3 plus or minus the square root of 15 times square root of I squared all over 2. Okay, so our equation becomes x equals 3 plus or minus the square root of 15. Now these two cancels this root, so we have square root of 15i all over 2. You should always note that, or you should always write this I. You shouldn't write this I under the root. It should be a bit far away from the root. Okay, so you can see this is not under the root. Okay, now so this is our answer. Therefore we can say s2 is equal to 3, okay, plus the square root of 15i all over 2, and then s3 equals 3 minus the square root of 15i over 2. Okay, the equation has got complex roots. Okay, so this brings us to the end of the process. Okay, all right.